Problem 5. Consider the differential equation dy dx equals 1 minus y. Let y equal f of x be the particular solution to this differential equation with the initial condition f of 1 equals 0. For this particular solution, f of x is less than 1 for all values of x. Alrighty. For part A, use Euler's method starting at x equals 1 with two steps of equal size to approximate f of 0. Show the work that leads to your answer. Okay, I'm going to start making a chart. And it said to start with x equals 1, and we need to get down to 0, and we're going to need two steps. So I'm going to do 0.5 and then 0. Okay, it told me my y value at 1 is 0. Okay, so from here, we know that delta x is negative 0.5, just FYI. All right, first step. So first step, we're going to have m equals delta y over delta x. My slope is going to be dy dx is equal to 1 minus y. My initial y value is 0, so that is going to equal 1. So now I'm going to have 1 equals delta y over my step size, which was negative 0.5. And when I do that, I'll get delta y equals negative 0.5. So I'm going to go down 0.5. 0 minus 0.5 is negative 0.5. Okay. My second step, again, will have m equals delta y over delta x. My slope this time is going to be dy dx is equal to 1 minus the y value. This time the y value is negative 0.5. So when I do that, I will get 1.5. So now I'm going to have 1.5 equals delta y over the step size, which was negative 0.5. That's going to give me delta y equals 1.5 times negative 0.5 is negative 0.75. So I need to go down 0.75. So negative 0.5 minus 0.75 is negative 1.25. All right, that would be worth 2 points. If you actually used Euler's method with two steps and organized your work kind of neatly, you're going to get a point. And then if you were actually able to find the right value, you'd get a point. All right, B, find the limit as x approaches 1 of f of x over x cubed minus 1. Right, the first thing, of course, that we would like to do on this one is just try to plug in 1. So I'm going to do f of 1 over 1 cubed minus 1. I notice that f of 1 is 0, and 1 cubed minus 1 is 0. So since that gives me 0 over 0, I get to use L'Hopital's rule. So I am going to take the derivative of the numerator and the denominator. The derivative of the numerator will be f prime of x, and then the denominator will be 3x squared. And then if I'm going to try to plug in 1 again, this will be f prime of 1 over 3 times 1 squared. And f prime of 1, to get f prime of 1, I'm going to go back up to dy dx, because that is f prime. And when x equals 1, I know my y is 0, so this will be 1 minus 0, which is 1. And then 3 times 1 squared is 3. So my proper answer for this one would be 1/3. So if you used L'Hopital's rule and you show that you were using it, give yourself an answer, a point. And you might want to, since we are actually hitting the big time test here, you might actually want to say that you are using L'Hopital's rule instead of putting LR, because they might not know what we mean when we put LR. Okay, and then you're going to get a point for getting the right answer. Alrighty, part C, find the particular solution to the differential equation dy dx equals 1 minus y with the initial condition f of 1 equals 0. Okay, second I see particular solution, I need to be thinking that I'm going to cross multiply. Okay, so we have dy dx is equal to 1 minus y over 1. I'm going to cross multiply, so I'm going to get dy equals 1 minus y dx. I'm going to then divide both sides by 1 minus y. So I'll get dy over 1 minus y is equal to dx. I do have my variables separated now, so I'm going to go ahead and take the integral. On the left side, since I have a denominator, I'm going to do a u substitution. So u will equal 1 minus y, which means du will equal negative 1 dy. I'm missing the negative on the inside, so I'll put a negative on the outside. So now I have negative integral of du over u, and the integral of that will be negative ln of u, so negative ln 1 minus y. And then equals the antiderivative of the right side will be x plus c. All right, I would like to do the logarithm loop, but I can't do that with the negative here. So I'm going to multiply both sides by a negative. So I now will have positive ln 1 minus y is equal to negative x plus c. At this point in time, I can do the logarithm loop. And if I do that, I'm going to get 1 minus y is equal to ce to the negative x. Right? I'm going to subtract 1 from both sides. So now I'm going to have negative y equals ce to the negative x minus 1. And then I'm going to multiply by a negative, so I'm going to get y equals ce to the negative x plus 1. And again, this one just stayed c. I didn't have to put negative c. If you want to, go for it though. All right, the next thing I would like to do is actually find c. They did tell me that x equals 1 and y equals 0. So I'm going to have 0 equals ce to the negative 1 plus 1. I'll subtract 1 from both sides, so I'll get negative 1 equals ce to the negative 1. To get c by itself, we'll divide by e to the negative 1. And when we do that, we'll get c equals negative. If this is on the bottom and it's negative, if I move it up top, it will become positive, so it will just be negative e. And then from here, just rewriting it, I'm going to have y equals negative e, and then e to the negative 1, or negative x, excuse me, plus 1. Right? This answer right here would be totally acceptable. I generally like to combine things if the bases are the same. So since the bases are the same, we can add the exponents. So this will actually be y equals negative e. If I add those exponents, I would get 1 minus x, and then it would be plus 1. All right, so this part was worth 5 points. If you separated your variables, give yourself a point. If you correctly took the antiderivative of both sides, give yourself a point. If you put plus c, give yourself a point. If you correctly found c, give yourself a point. And then if you were actually able to go back and solve the equation, give yourself a point.